Welcome to Unit 3, Lesson 4, End Behavior of Rational Functions. Let's explore the end behavior of rational functions. Okay, so let's look at this one. We had to divide. So in the problem on the left, 2775 is the dividend, 11 is the divisor, 252 is the quotient, and 3 is the remainder. Because we have a remainder, we know that 11 is not a factor of 2,775. So now, what we're going to pay attention to is not the middle one, but the bottom one. So what we have to do is write the quotient by itself plus the remainder plus the rest of it as the remainder divided by the divisor, or the remainder in the numerator and the divisor in the denominator. So we're going to repeat these steps, but we're going to have a polynomial. When you divide a polynomial by a polynomial, you get another polynomial. So I'm going to do the math, and we'll come back and explain it. Okay, so we did 2x squared times x, and then 2x squared times 1. We changed both signs. We subtracted. We got 5x squared. We brought down our next term, our 7x. Then we multiply to match the first term. 5x times x is 5x. I forgot to write that as a square. This should be 5x squared here. We multiplied. We changed both signs. Then we added or subtracted. 7x minus 5x is 2x. We bring down our next term, which is 5. We multiply to match the first term, so we multiply by 2, giving us 2x, and then 2 times 1 is 2. We change both signs. The first term cancels out. We're left with 5 minus 2, which is 3. 3 is our remainder. So to write it, the middle one, you put the factors next to each other and then put the remainder. The third one, the one that's highlighted, is what we're going to concentrate on today. Write your quotient, because this becomes your asymptote, and then your remainder, or the unfinished part of the division, it eventually goes to 0, because the degrees are different. The degree in the denominator is higher than the degree in the numerator, so as x gets very large, that term goes to 0. So our asymptote is not a horizontal or vertical. It's actually a slanted line at 2x squared plus 5x plus 2. Okay, so several conventional cars have a fuel economy that is about 10 miles per gallon higher for city driving. So what we're going to do, they give us this, h equals x plus 10. So we're going to substitute x plus 10 and for h into our original equation. I'm going to show you the substitution. So I get, if I pick the right marker, 100 x h. Always use parentheses when substituting. And then we're going to divide that by 55x plus 45x plus 10. So now when I distribute top and bottom, I get 100x squared plus 1000x over 55x plus 45x plus 450. That gives me 100x squared plus 1000x over 55 and 45 is 100x plus 450. Now, rewrite f in the form q of x, polynomial plus r of x over b of x, a rational function. So what we're going to have to do is now go 100x plus 450 into 100x squared plus 1000x plus 0. We have no constant. And we'll continue this division on the next page. Okay, now that we have our problem set up, we're going to do 100x plus 450 divided into 100x squared plus 1000x. We have to put a 0 in because we have no constant term. So x times 100x is 100x squared plus 450x. Change both signs. We get 550x. Bring down our 0. We need it for place value. So now, what do we multiply 100 by to get 550? There's no one number. So if you do 550 divided by 100, you're going to get 5.5. So if we're going to add 5.5, you're not really supposed to have decimals in division, but whatever. This is a case. And then we get 2475, 5.5 times 450. Change both signs. You get negative 2475. Okay, so our answer is x plus 5.5 minus 2475 over 100x plus 450. I think I could take 25 out. 75 ends in 25. So does 450 and 100. I could take 25 out of this. So I'm going to divide 25 out. I'm going to factor 25 out of each of these terms. When I do that in the calculator, I get x plus 5.5 minus 99 over 4x plus 18. This is a weird number, but this is our answer. And that is the remainder, 99 over 4x plus 18. Okay, I'm going to do each of these on its own separate page. So each page will get its own one. So we're going to start with the degree of the numerator. The numerator of g has no variable. So because it has no variable, it has a degree of 0. The degree of the denominator is 1. So because we have no variable, q of x, our polynomial, is 0. Minus the fraction r of x over b of x, the rational part, is 5 over x plus 2. All right, in behavior, we know that any constant over x goes to 0. So y approaches 0, or y goes to 0. It does not touch it, it approaches it. All right, now let's look at h. Okay, now the degree of the numerator is 1. The degree of the denominator is 1. Now, we're not worried about the vertical asymptote. We're worried about the horizontal asymptote. So what I'm going to do is do long division to find the horizontal asymptote. You have to long divide. And x goes into 7x 7 times. 7 times x is 7x plus 14. Change both signs. You get negative 19. We don't do anything else. So q of x, our polynomial, is 7. Our rational part is 19 over x plus 2, because x plus 2 is our divisor. In a fraction, our remainder goes over the divisor, and our end behavior is y goes to 7. We're only worried about the whole number quotient, the polynomial that comes out, not the rational part. Okay, for the next one, the degree of the numerator is 2. The degree of the denominator is 1. So this is going to be a little interesting. So when we long divide this one, we get 3x squared plus 7x minus 5. I might have to move this down a little bit, but whatever. 3x goes there. 3x squared, 6x, change both signs. You get 1x, bring down your negative 5, plus 1, x and 2, change both signs. You get negative 7. So our polynomial is 3x plus 1 minus 7 over x plus 2. Our end behavior, y goes to 3x plus 1. When we say y goes to this is our horizontal asymptote. We also have a vertical asymptote. So how do you find a vertical asymptote? Vertical asymptote, you set the denominator equal to 0 and solve, and you get x equals -2. So that means all of them have the same vertical asymptote. And I'm glad they use the same denominator for all. Okay, for k, we see that the degree of the numerator has a 3. The degree of the denominator has a 1. Let me change colors. So this should be 3 and 1. So now we're going to have to long divide this. X plus 2 into 2x cubed plus 3x squared plus 7x minus 5. I like how they're using the same polynomial. They're just adding a new first term. 2x squared gives us 2x cubed, 4x squared. Change both signs. We get -1x squared. Bring down your plus 7x minus 1x, because you have to multiply to match the first term. Minus 2 minus 2x. Change both signs. First terms cancel out. You get 9x minus 5. We times that by +9, because our leading term now is 9x. You get 9x, 18. Change both signs. You get -23. Okay, so our answer, our polynomial, is the quotient 2x squared minus 1x plus 9. Our rational part is -23 over x plus 2. So what do we say? Y will go to 2x squared minus x plus 9. We don't worry about the remainder, the rational part, because we know any constant over x will go to 0. So this is going to look goofy in the graph. I want you to graph all of these so that you know what they look like. And I don't have time to show it on the video. And finally, the last one. The degree of the numerator is 1. The degree of the denominator is 3. Because the degree of the denominator is bigger than the degree of the numerator, it's going to go to 0. Plus x plus 2 over the rest of it is our rational part, just like the first one. And then y goes to 0. So we have a horizontal asymptote at the x-axis. So that's what we get.